Okay, so here's part 2 of the 2.7 extension day 1 notes. Now we're going to go over how do we graph piecewise functions. Well, how we're going to do so is by using XY tables. So when we use XY tables, the number of equations we see in our piecewise function, that is how many tables we should create. Because we want to make sure that we can list the values or the points that will work. Okay? So I'm going to kind of keep this color coordinated here. So let's keep this as 3x plus 1. Okay. Now, let's look at 2x minus 1. How do we know which values to plug into our XY table? Well, this is always going to go off of your restriction, okay? So notice this says x is less than or equal to 1. 1 is part of our restriction, so we need to start with that number. And that's going to be at the x, because remember, the restrictions are dealing with the domain. Okay, now we need to pick probably 3 other points that are going to be less than 1. Well, that can be 0, -1, and -2. Now, what we do is we plug these x values into our equation, 2x minus 1. So when we plug 1 into there, we get 1. When we plug 0, we get -1. When we plug -1, we get -3, and then we should get -5. Okay. Now, let's look at 3x plus 1, okay? So, here we have a restriction. We are still actually on our x values going to start at 1. Now, some of you might be wondering, well, why are we doing that? There's no equal bar underneath it. Well, we'll talk about that in a little bit, okay? But for now, anytime whatever your number is on the restriction, that needs to be the first number you put in your x for both of them, okay? Now we're going to figure out, well, what numbers are greater than 1? So we can do 2, 3, and 4. Okay, let's plug in our x into the equation of 3x plus 1. So we should get 4, 7, 10, and 13. Okay, so now our next thing is to plot these points. Now, before we do this, we need to talk about open and closed circles. Now, remember, when we did absolute value inequalities, we talked about open and closed circles when we graphed it on a number line. Remember, anytime we have an equal bar, that's actually when we're going to have a closed circle. Anytime we have no equal bar, we're going to have an open, okay? So on the 2x minus 1, because we have x is less than or equal to the equal bar, our first point of 1, 1 is going to be closed. Okay, so let's go ahead and plot that. So we have 1, 1. Now all the other points are also going to be closed, okay, no matter what. Because we want to make sure this is a graph, everything is included. That's 0, -1, boom, boom. Okay, now how are we going to draw this? We need to go from the very first point we plotted and connect the rest of the points. So you start from 1, 1, connect the rest of the points. And no, this line goes on forever, so I need the arrow. Now, if you look at this, do you guys recognize what this is? This is probably from geometry. This looks like a ray. We have a starting point, and then we go on forever in the other direction, okay? So for a lot of these, either we're going to draw rays, or you're going to see pretty soon drawing segments, okay? Okay, now let's talk about the next one. We have 1, 4. Now notice here there is no equal bar, okay? So since there's no equal bar, we are going to have an open circle, just like we did with the absolute value inequalities. Now, though 1, 4 is going to be open, every other point is going to be closed, okay? So we go to 1, 4, 2, 3. Have that open, but everything else is going to be closed. 3, 1, 2, 3. There we go. And once again, I do the same thing. I go from the starting point of 1, 4, connect the dots, and then I do an arrow. Okay. Now let's talk about why did I have to do this? Why didn't I just start at 2? Well, the reason being is going back all the way to the idea of being a function, okay? So for every x value, we have one exact y. Now remember, closed means that it's part of the graph. It's included. But if we have an open, it's not included, okay? So that's why we have to have an open and a closed. Now another reason why we have to start at 1 on our second XY table, though there is no equal bar, is because if we didn't and we just started at 2, which is going to be 2, 7, we are missing all the points in between them, okay, between 1 and 2, all these values. And all those values are going to be part of the equation. So meaning like 1.5, well, that has to be part of it because 1.5 is greater than 1. And we'll be missing like 1.1, okay? So all those x values in between 1 and 2 we would be missing, and that would mean we would have a gap in our graph. And we do not want to have a gap. If we have a gap in our graph, it is not a function. So that is why we have to, on both XY tables, start at the restriction, no matter what, if it's an equal or no equal bar. Okay, let's try the next one. So our next one, we're actually now going to have 3 equations, meaning 3 tables. Okay, so we will have, let's do this. Yeah. -3 has x minus 1. Then we'll have x plus 1. And then 3. Okay, so now we're going to do the same thing. On this first one, -3 has x minus 1, let's figure out what is going to be the first x value. So we have x is less than -2. Now, hopefully you said, well, -2 is going to be our first point we're going to have for x and not -3. Because remember, that's going to leave a gap, and that means it is not a function. We cannot have any gaps. Okay, so we start at -2 because that is part of the restriction. We have to start there. Now we pick numbers that are less than that. So we have like -3, -4, and -5. Okay, so now we can plug those points into our equation here, and we should get 2, 3.5, 5, and then I think this will be 6.5. Okay. Okay, now let's go on to the next one. We have x plus 1. Now notice here, this is looking a little bit different. The last ones that we've been working on, they only had 1 part to the restriction. This one has 2. Because it has 2, we have to involve both of them. So I'm going to place -2. I'm going to leave some room and also put 1. So if you have 2 numbers for your restriction, you have to put both of them in your x or xy table, okay? Now we're going to choose some numbers that are in between -2 and 1. I'm going to go ahead and put 0, or I'm going to do -1 and 0. There we go. So now we just plug these values into our x plus 1. So I get -1, I got 0, 1, and 2. Okay. Lastly is going to be our 3. So for our x, notice we have x is greater than 1. We have to put 1 in our xy table. Remember, no gaps. So whatever that restriction is, you need to plug that into there. Now I need to find numbers that are greater than 1. So that could be like 2, 3, and 4. Now you might be wondering, but there's no x here. How can I figure out my y's? Remember, when it's just a constant, a number, that is going to be the y value for every single x, okay? So this is going to be 3, 3, 3, 3, because that's our y value, okay? So anytime you have a constant, make sure that is your only y value there, okay? So now let's go ahead. We're going to plot these points and figure out open and closed circles. Okay, the first point we're plotting is -2, 2. Notice it is no equal bars, so we're going to have an open circle. So I go to -2, 2. Okay, and then I go to -3, 1, 2, 3, 2, 3.5. Everything else is closed though, okay? 4, 5. There we go. And then continuing on. Okay. Then we have 6.5, so we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh, that should be 5 there. That's why. And then 6.5. There we go. So we go from the very first point that we plotted, connect the points, and we create an array. Okay. Okay, next one. Now here we have 2 points because we have 2 parts to our restriction. On both of them, they have an equal bar. So that means both of them are going to be closed circles. And then everything else in between will also be closed. So I go to -2, -1, and then -1, 0, boom, and then 1, 2. Once again, I go from 1 point. Now notice here, this is a little bit different. We see that we have a segment. We have where we start and we stop. So anytime we have 2 parts to our restriction, we're actually going to have a segment, and there are no arrows there. Okay? Okay, lastly, 1, 3. So notice there's no equal bar, so that's going to be an open circle. I plot that point, 1, 1, 2, 3. Okay? And then I do all the other points, and those are going to be closed. Okay, so make sure all the other points are closed. And notice here that we make, once again, an array, because we only have 1 part to our restriction, but we have a horizontal line. So anytime that you have a constant, it should be a horizontal line here. And then we do have an arrow because it is array. Okay, make sure you watch the last part to these notes. Once again, we're going to be graphing piecewise functions.